everyone! I wanted to give you a quick update. It's been a long silence over essentially what was the last half year, and sadly the Atmoventus project didn't really go forward in that time all that much because, well, our old favorite little virus and uni and all kinds of stuff came together to slow us down to a crawl. But it's summer holidays, and as you know, every holiday we really take a leap forward. This is our MCP 3.0, already updated though. Our version 3.1 is on the way with a lot of crucial improvements, but the real biggest improvement over the last half year is this. We are now using the TNC 4.1. It's gonna be on the MCB like this, obviously soldered on, not just light on top, duh. And on the 3.1 it's gonna be just like that as well. And what I wanted to do now is just give you a little overview on how much improvement this thing is gonna give a rocket. So what I wanted to do here is just show you how much improvement this TNC is gonna give us over the CPUs we planned to use in the past. I loaded the exact same program on this thing that also ran on our last video. It looked very janky back there. I also had the whole TVC connected. It ran at 72 Hz, so the whole calculation loop finished 72 times each second. I do not connect the TVC here. It does exactly the same calculations with just arbitrary numbers or set numbers, but that doesn't change the time it takes for these calculations. And what I'm going to do is just switch on and off pin 2 every time it ran through the circle once. Over here I have a small oscilloscope, and we will measure how fast pin 2 is gonna switch on and off. So we got 72 Hz to beat. Obviously I tried this before, which is also a reason why I'm so excited to show you. Right now we just have some random chatter in the line, and I will now connect the power. We will observe what happens. And now we see quite a lot of weird signals, which is because the whole board is not soldered into the pins. So if I push it to the side, we should get a clean signal, and there it is. There, we got a beautiful signal. If you look closely, that's 2.7, 2.9, maybe 3 blocks it takes between each on and off. With a scale of 0.1 milliseconds for each square, that means that we take a maximum of 0.3 milliseconds for each run of the calculation loop. And if I then punch that into our good old trusty calculator, we get 3.3 kilohertz. We had 72 Hz to beat, and we beat it by, well, essentially all of the hertz. So yeah, that's where this project is right now. Our electronics are pretty much done for. Most of them are already ordered, on the way or here, including the MCB 3.1. Dennis is working hard on an interface as well as on our second little MCB cutoff, because over here you see some holes up here which connect to our GPS and radio communication, which are located not in the bowels of the rocket but the tip. The tip is going to be made of glass fiber as well instead of carbon fiber, because carbon fiber is actually a conductor. Carbon is a conductor. So if you put radios or antennas in general inside of a carbon tube, you will not have proper connection, because it's the same as putting it up a metal tube essentially. So we put it in the tip. We have a second little board for that, which is also coming soon as we know how exactly our GPS and communication is going to work. So yeah, that's that, and I'm now gonna go back to being happy, also soldering these pins on. I just couldn't be bothered to wait for making this little video because I'm so hyped. And then get it running with our TVC, which also now has power wave modulation for the speed of the actuators, so lots and lots of very nice stuff, and expect for a very impressive result, well, at least for me, coming soon. And if you want to see what all that cool stuff is, then, well, subscribe. Duh. Why do people even have to tell people? It's 2020. Why do we have to tell people to subscribe? I don't get it.